something like that, a bunch of tools on the outside, you know, bunch of tools on the outside. Well, each tool comes to the origin. Not necessarily, it knows where the origin is. So what the geometry offset. So if my machine zero, when people design the machine, they can only tell the machine go home, and that home is considered zero. Those parameters, those values for the machine zero are held. When my machine is not running, I turn it off and I go home. Those parameters are held by batteries. There is batteries in the back of the machine that basically keeps those values. Now the machine zero is a set of parameters for the machine that knows, hey, this is my zero position. Good. Now we have origin over here in SolidWorks, mastercam, where we think that's the zero position. Well, then the machine has its own zero position, and mastercam and SolidWorks has its own position. So we have to bring those two together in order mastercam, SolidWorks, and the machine to talk the same language. Other than that, the machine has its own zero. SolidWorks and mastercam, they have their own zero. I know SolidWorks and mastercam, they like each other, they agree, so they know their origin. But my machine is way out there. The turret zero position is way out there. So I have to bring this zero of the machine or transfer it. By what? By a geometry offset. Now, if the machine is zero over here, or what I'm just talking about, let's say, if the machine is zero over here, there is a z value from this spot all the way, z value, and then from this spot all the way, x value. So delta x, delta z, and delta x. Those values comes over here. I mean, that is actually, sorry, and then it comes over here, and then this is the same. It's a rectangular shape. So the distance here, and here, and that distance the same. So they bring us to this. Well, the x, delta x, and delta z, those are my offset geometry values. So these two numbers would bring the zero position of the machine to the origin. Now, what do I have? SolidWorks. SolidWorks, mastercam, and machine. They all are to the origin. They are with the help of the geometry offset. So in today's lesson, I just want to make sure that everybody understands why we use geometry offset. The reason we use geometry offset is because we want to bring the machine zero to the origin. Now the program, which is mastercam, goes from the origin and up, and all those x value and z values within the program will help the tip to move in whatever direction, usually the upper half, as well as on the negative z, because my part starts on this right here and goes this way. My part is on this side. It's actually on the second quadrant of the z x-axis. It's on this quadrant. This is where you do a lot of your machining. So, question for you. On your program, the values of z's, of the values of all the z movement, do you think is positive or negative? Look what I just said. The question is, in your program, who gave me the program? mastercam. The program that you're looking at your part, that was given by mastercam following all the different tool paths, what do you think is the value of Z on the program? Because Z has like, numerous numbers within the program. And all of them, you look at them, do you think you should see a positive Z or a negative Z?
Negative.
Thank you. It's all going to be negative. Why? Because our part is located on this side, which is the turning profile from the origin to the left, which is all Z values better be negative. If you see Z value that's positive, especially you're entering manually, you're doing something wrong. So it better be all negative. How about X values? Because we're going to be going from here and we're only doing turning here, going up and down, maybe, whatever. What do you think of the X values?
I think it's positive.
Positive. Sometimes, because you might have a tool that's reversed. Sometimes, I don't think it happens a lot, but most likely it doesn't. But in some certain situations, it's possible you could have an X that might be. Look, I could say 99.99% they're positive X-axis and negative Z values and positive X values, okay? Because especially if your machine has, the turret is coming from the upper right corner, that's always the case. Because there are some turrets that would come from the bottom here, from the lower right corner. So now you're turning the lower. Now we're not talking about those machines. Why? Because that's not the kind of machine we have. Our machine, the turret comes from the upper right corner, and the spindle is on the left side. There are certain machines that have two spindle, two turret. That's a different story. We don't want to even talk about that because we don't have machines like that in our shop, okay? So let's just skip that for right now. But once we get into those machines, if you understand the basics here, it doesn't really take a rocket scientist. You can figure it out on your own. But if you need help, I will help you, okay? So today's lesson is nothing but how you can set the zero position of every tool. It's geometry offset, delta X and delta Z. To do what? So that the machine its tip is back here at the zero position. So we enter all those offset value and what? And all the tools that you set, they know they're at the origin. So the machine, the tip tool is at the origin. Mastercam is at the origin, SolidWorks is at the origin. Now everybody is talking the same language. Let me ask you this question. If the machine 0 is out here, which is X is 0, Z is 0 over here, what do you think the values of the offsets are? Are they, which one is negative and which one is positive? Remember, it's going this way. Remember Z, the machine, Z machine, and this is X machine, 0 is here. Now I'm moving this way to bring it here. Do you think delta X and delta Z, are they always positive? Are they always negative? Are they always a combination? What do you think?
Always negative.
Good job. Always negative, because this is my 0. I'm going Z on the negative side. And to bring it down here, because remember the turret comes this way, goes down, my X is also negative. So always, my delta X is a negative number, my delta Z is a negative number. So when you go look on the offset geometry on the machine screen, the values are all negative. Are we clear here? Do you have any confusion why we need the offset geometry? What's the purpose of the offset geometry? Can someone tell me? Good, this time.
English or
however you want to do it. It's up to you.
Celestian SolidWorks mastercam our machine ክረዳዳ አመንቲ geometry offset ክንፈጥር ሓንቲ ዜሮ ክንፈጥር ኣለና that's why ናት ያ ንፈጥራ
Okay. So bottom line is just saying he wanted the machine, mastercam and SolidWorks to start from the same origin. Then we have to deduce the geometry offset. Now, in your program, your machine calls T, let's say we want to take maybe tool number 4, it's going to say T0404. If we select, like, for example, tool number 4 is doing some kind of work in the program, the call out, the way your tool is called in your program using mastercam is going to say T0404. If that is the case, the two last digits are the offset values. The 2 digits here is the tool number, and T is basically tool. It represents tool. So the first 2 digits tell you tool number, and the 2 digits right here is called offset, geometry offset values. So means it's using those values. So that when that tool comes, it will know it's using those values to bring the tool to the 0, and that tool is tool number 4.
I want to make clear on that geometry offset. When you say, let's say for delta x it's 0 and a delta z is 4, is that what you mean?
Oh, no. Those are basically a designation. It's called T. When you call a tool, remember our AC150, it could load up to 12 tools, right?
Yeah.
The TMC loads 10. The other one, the 250, loads also, I think, 12 or 10. I don't remember now. Okay. Now we got, let's say TMC. Let's take the TMC. It has 10 tools, right? So my tools will be tool number 01, tool number 02, tool number 03, tool number 04. It goes all the way to 10. Tool number 10. Right? Now my offset is also 01 on here for tool number 1, 02 for tool number 2. They basically match that, but they have a meaning. The last 2 digits I said, it represents the offset geometry, this value right here. When that tool is coded on the program, it will automatically say, hey, with that offset
So
value.
my question is, can you tell the delta z and the delta x from there?
From this designation?
Yes.
No, you can't tell.
Okay.
But the machine knows, because that value is already entered in the screen.
Okay.
Okay? From here, they're just like, you would never call something called T0403. It doesn't have any meaning, because you're saying, hey, 204, okay, an offset 03. You're trying to use an offset for tool number 3.
Mix.
That's mixed, because you didn't send them tool number 3 has its own shape, its own insert. They don't even have any kind of relationship. So this is always the same number, okay? It's 204 and 04. Or if I want to select 203, it's 20303. That's how they're called in the program. Remember, when we start generating programs and start running parts, you will have an idea of like, oh, okay, that makes sense. All I was trying to say today was nothing, offset geometry, why we use offset geometry, and today's lesson on the actual hands-on training is going to be, we're going to take 2 machines, run them both, and you're going to start setting up the offset geometry. What buttons you have to push to basically use the offset geometry to bring every tool tip. We're only talking about the tip of the tool. We're trying to establish its 0 position by using the offset geometry. Is that clear? Okay, I guess we're going to go back to the machines and do our thing. So I had to go through this explanation, because if this doesn't make sense to you, that means you really don't know what's going on. And if you know these, you pretty much are almost 75%, you're already a machinist. If you know how to set up your tools, you're already 75% you know how to run the machine, because the others is basically pushing buttons. Mastercam will give you the program. What else do you need to know? How to tighten the stock? Yes, sir.
Right. On the SolidWorks and mastercam, the origin is 00, yeah?
Yes.
But here on the machine, it is 00 is where the machine is.
Where the machine is a
It's
00.
00.
So in
And
order
then
for
moving until we get into the origin, it has to be positive or negative. Until the negative side in the representation is from the left to the origin.
I think your question was if
Everything
let me
moves
see if I
from-
understood your question. You're saying for mastercam on SolidWorks, the origin is, it's like virtual thing. You could see it, it's right there. Once you turn on your grids, you know where they're at, right?
Yes.
And depending on which plane you draw, if you draw something on SolidWorks on top plane and on mastercam you open it, it will always match. It's gonna match. But if your part is gonna match, okay? But if let's say you drew it on SolidWorks on a different plane, then you have to move the part around or rotate it or that kind of thing. But now we already know that part where we draw everything on top plane and then we open it using mastercam. Now they both have the same origin. No problem, they match, right?
Yes.
But your machine location, the machine 0, is a value that is entered by the manufacturer to be all the way on the upper right corner because you want to get out of the way. You don't want to put your machine 0 over here, then how are you going to change the turret? The tools. Things will collide over here. So what they did was, for safety purposes, your turret has to be all the way in the upper right corner. Well, they defined that point to be the 0 point of the machine, or they call it home of the machine. Home means when you're finishing, you're going home, you put it at home, and it's sleeping. So that is called the 0 position of the machine. Now, I want to make sure the machine, in order to communicate with SolidWorks and mastercam, I have to use something called offset geometry. Those values would bring the tip location of every tool to the 0 with its respective offset geometry, that's why every tool on your program, when you call them, or when you use mastercam and you try to call, they have the tool number and the offset geometry, as well as tool location or a station, which is kind of matches to the tool number, because on the turret, on the face, if the turret holds 10 tools, that is 0, 1, 0, 2, 1, 2, 3, 4, all the way to 10. So that's permanent. It's already either engraved or, it's like some numbers, it's there, right there, you can see it. So you just basically hook your tool holder into every location, and then you put your tool inserts or whatever is holding them, attach them there, it's done. Now we know. Now every tool tip has to have a geometry set values for it to come to the origin. If it doesn't have those values, then you're way out there. The machine is saying something else. And by the way, there is another thing I wanted to say. If I say tool number 4, 0, 0, what does that mean? It means tool number 4 without geometry set values, without that. Okay? So when you establish the offset geometry, you go to the MDI mode. You switch your thing to the MDI mode, and then you enter 20400. That's what we're going to do hands-on today. And then you say, hey, select that tool. It will bring that tool with any offset geometry. Now you have to go to its respective location, bring it to the origin. And that is kind of like hands-on training today. Daniel and David were here yesterday all day. They know exactly how to do it. But it's not that easy, because sometimes you have to move everything manually. You're going to use the handle to move around your turret. You have to use some switches, so you're gonna have to do it over and over so that it will sink in. But right now we're just explaining the basic, why do we have a geometry offset, what is the purpose of that. And without a geometry offset, do we have the machine, mastercam, and SolidWorks communicating from the same point? No, we don't, if we don't have geometry offset, because the machine has its own 0 position. You have to use those numbers to bring it to the origin. Now all three are shaking hands. They are talking the same language, okay? Clear? All right. So we're going to go to the machines.